All right, so today we're going to talk about data cleaning. This is probably the least glamorous part of data analysis projects, but also probably the most time consuming. Data cleaning and transforming and all of these things it can be up to like 80% of any data analysis project. So it's a really important topic to cover and a really important thing to be able to do. So we're going to start by installing a few more packages that we have not yet installed. The first one is LubaDate, which is a way for working with dates, and the second is Dippler, which you may have installed with the first tutorial. So we'll get started by typing install, click on it there, install.packages. Our studio helps me there. And then we'll start with LubaDate and then install.packages, and we will call DPLYR, Dippler. Dippler allows us some better data handling, better data manipulation over what comes in base R. So I'm going to highlight both of those, and I am not going to run them because it's going to take a minute and I've already run them. Okay, so once you have installed LubaDate and Dippler, we will call them. So we'll call library LubaDate and the library Dippler. We are also going to use the tidyverse. So we'll call library tidyverse. Pretty much always when you're doing any sort of data analysis, you will use the tidyverse library. Okay. And in the course, the LMS, you have two data sets. The first is the mealplan.csv dataset, and the second is the H-1B visa dataset that we worked with before. Today we're actually going to clean it so we can do the things that we want to do with it. But we're going to start with the meal plan dataset. So go ahead and download that if you haven't already. You probably want to pause this video while it downloads. And then we're going to load our dataset in. We're going to call it meals. And we're going to say read.csv. And we'll go to mine is on the desktop. The way that I got this nice drop down was I hit the tab button. So I wrote read.csv, opened quotes, and hit tab, and I get desktop. And then I have the info 640 labs folder, and then it has a datasets folder, and then it has this mealplan.csv. And I'm going to specify that header is equal to true. This is just saying to read the first row as the header column. Now, a little bit about this meal plan dataset. It is the meal plan for a cafeteria in the world that is serving, meals most days. Okay. And it is a fake dataset. I made it specifically for this. But it's small enough that you can look at all of the variables, which is not really true with the H-1B dataset, or rather you can look at all of the rows. With the H-1B dataset, like you saw last time, it's too big to be able to inspect everything all at once. So we're going to use this meal plan dataset first, do a bunch of transformations in order to get us ready to address the H-1B dataset. Okay. So we'll go ahead, we'll run this line, and it brings this in here, and it gives me a warning. So you probably have a similar warning. It might be slightly different than this. This is a warning that LubaDate is passing us, and it's saying, I don't know this format that your computer is set in, so I don't know what to do about it. Okay. And you probably don't have this second warning message because I just went out and fixed the data set. Don't worry about what this is. It has to do with how I formatted the CSV. But yours should read in nice and neatly, like this meals to read.csv and header true. And once you have that, you know that it's loaded. Okay, so let's make sure that it actually read in as the data frame that we were expecting. So I'm going to call class on this meals function. And I'm going to say, what is your class? I'm going to go ahead and run that. And it says, oh, I'm a data frame. Okay, that's great. What are your dimensions? So I'm going to pass dim, meals, and what dimensions do you have of a data frame? Oh, so this is telling me that there are 3 rows and 7 columns. The way that R always works is you pass rows first and columns second. So whenever you're slicing your data set or whenever you're trying to figure out the dimensions, it's always rows and then columns. Okay, what are the names of the variables in my data set? This is going to help me with organizing and figuring out what's going on here. So I'll run that to find out what my names are. And it looks like I have some column headers here. I have meal, and then I have a bunch of dates. And I know that this is probably not a tidy data set. It does not follow the principles of tidy data. I'm going to keep that in the back of my mind and know that I'm going to have to address that later. First, I'm going to keep getting a good picture of my data and understand how it's structured, but I'm going to flag this as I need to come back and fix the dates. Working on my own, I'm going to make a note on a piece of scrap paper that says, come back, there's dates in the header names. Okay, you don't have to do that, but I like to go slow and take notes. It helps later on. Okay, so let's find out what the structure of this data set is. So I'm going to call str and pass it the meals variable. Go ahead and run that. And the structure of my data is that I have a data frame, and there's 3 observations of 7 variables. I have the meal variable, and it's a factor, so that's my data type, with 3 levels. And it only tells me what the first level is, but tells me that there are 3. And then I have a bunch of dates. So these are read in factors with 3 levels. So there's 3 variables in each. And it looks like I have some combined data. It looks like I have both the entree and the price in the same set. So I'm going to have to work on that later. So I'll make a note that I need to come back and split up that column. And finally, I have the location. And it looks like this is telling me that I have break rooms and dining halls. So this is a factor variable with 2 levels. Okay, I have a pretty good idea of my data set now. Now I'm going to ask to get a glimpse. And this is what comes in with Dippler. This is not base R. This comes in from the Dippler package. And the glimpse, as you'll see, gives us a lot more information. We see here that it's telling me it's a factor, and it's giving me as many of the variables as it possibly can, and way fewer of the useless dots and commas. So Glimpse will format this a whole lot better for you, showing you more of what your variables are. Okay, finally, let's ask for a statistical summary. It's not going to be terribly interesting for this particular data set, but you should still know that it's there. So we'll call summary meals, and what this does is gives me some statistics. So this will typically tell me what my highest value is, what my lowest value is, and the breakdown of those values. This will be more interesting on the other tutorial. Okay, now even though we have all of this data about our table, there's nothing that can substitute for seeing what the data itself actually looks like. So I'm going to ask for the beginning of the data. So I'm going to say head meals. And what this does is it'll give me the first 6 rows. So the default for head is 6 rows. However, my data frame only has 3. So for right now, it'll only give us the first 3 rows. Just so you have it together, we can also call tail on our meals data frame. And we can see what the last 6 rows are. Again, we only have 3 rows in this data frame, so these are kind of silly. All right, so let's get started with actually cleaning this data. Now that we have a good sense of what it looks like, the first thing that we're really going to want to do is pivot those rows that have information in the column headers. January 18th, January 19th, etc. can all be grouped together under date, and they should be. And the reason this is the first thing that we want to do is that we're going to do a lot of transformations on this afterwards, but if we don't have the right shape for our data, we might have to do those transformations multiple times, or it'll just be more steps in doing those transformations. So the first thing you always want to do is reshape your data. R makes this really easy. So I'm going to do good practice and make a new data frame, and I'm going to call it meals1. And I'm going to set meals1, and I'm going to say what I want you to do is gather the meals according to date, and the things that are in the date I want to be the value. Don't gather the meal column, and don't gather the location column. Okay, let's break that down just a little bit more. So I've given it the data frame. I've told it what I want the new column header to be. So January 18, 19, 20, these are all dates. So I want it to be a date. And then underneath those, I want those dates to be values. So my other column name is going to be value. Okay. This is a placeholder because I see down here that I have like oatmeal, 250 is one of my values. And that's not going to be my final data frame, or that's not going to be my final column name. Those are not my variables. So I've given it the data frame to target. I've given it the output column and the second output column. So it's going to gather together all the columns, and everything that's inside of them, it's going to put in the value column. And now I'm saying, don't touch meal and don't touch location. Those are both okay. So I'll go ahead and run that. Attributes are not identical. They will be dropped. That's fine. And I'm going to look at the head of my meals1. And I have way more of what I want to have. I have my meal, my location, the date, and the value. Okay. This value obviously needs to be broken apart. We have some weird formatting issue over here that we want to address. The first thing is, let's go ahead and break apart the entree and its price. Okay. So this is actually kind of cool, how direct this is. So we have meals1, our data frame. We're going to set that equal to separate, and I'm going to tell it to separate on the meals1 data frame, the value column, and separate into entree and price. And it looks like they are separated by a comma. Okay, so let's break this down a little bit. Just like in gather, we've given it the data frame. We've told it which column to target. And you see, unlike gather, we have to specify what to target. We have to say, oh, go and look for the value. We could also do this by saying, don't touch meals, don't touch location, don't touch date. Usually when you're using separate, that's not what you want to do. Usually tell it, hey, go look at value, or go look at the column that I'm interested in. And then turn it into two different columns. One is price, or one is entree, is going to be my title. And note that I've put it in quotes here. And that's because I'm passing to R a character or a string, and I want it to be exactly that. It's not yet the name of anything. It's still just an exact match it's trying to make out into the world. So we have entree and price, and these are separated on a comma. Okay, go ahead and run this. And it's warned me that it's filling NAs where there's no data. That's great. That's exactly the behavior that we wanted. So now let's see what our meals1 looks like. We'll call head on that. And we have the entree and the price. And it looks like we're making progress here. So now we can start dealing with our dates. You see here that our dates are separated by dots or periods. We also know that they're probably factors. They're not being read currently as dates. And we can go ahead and check that by calling glimpse again on our meals 1 data set. Run that. And yeah, our dates are characters, which is not what we want at all. So we need to transform them into dates. And this is where LubaDate comes in. So I'm going to call the meals 1 date column. And note I've separated the data frame, meals 1, from the column name with a $sign. And this is how you always select a column from any data frame, is you say, here's the big thing, $sign, go find the more specific thing. Later, we will select multiple columns at a time, but for right now, just worry about selecting one column at a time. In this case, the date column. And we will assign the date column to month, day, year of meals 1 date. Okay, I'll break that down a little bit. Okay, so the LubaDate package brings in all of these different functions for separating your dates into date time values. So our dates are written as month, day, year. If they had dashes between them, if they had January written out completely, if it was 01/18/2018, all of those are month, day, year. As you might expect, LubaDate can also parse dates that are day, month, year, as is more common in the rest of the world. So what you are telling LubaDate here is the order of the variables, or the order of the information. So first, it should look at all the possible ways to write months, then look at all the possible ways to write days, then all the possible days to write years. This is extremely effective. I have yet to find a case where it cannot parse the date so long as I passed it the correct order. Okay. So we'll go ahead and run that. And then we will ask again glimpse of our meals 1 to make sure it worked. And excellent. It is telling us now that this is a date data type. And note that it has transformed it into year, month, day. If you had asked for hours, minutes, seconds, and if you had that information in it, it would use the UTC default date and time. So we will not work with that this time, but you have enough knowledge here to go out and look for hours, minutes, seconds, if that's relevant to your project. Okay, so the next thing is I'm looking down here at this price, and it has a $sign. Now, $signs are great because they tell us that we're talking about money, right? $signs are not great when you're trying to do things like add. So we are going to remove the $sign in our data set to prepare it for analysis. So just like we called date before, I'm going to call price. So the meals 1 price, and we will assign it to this function. So what we're doing is we are going to substitute, and we have to use a regular expression here. For the time being, don't worry too much about what that regular expression is. It's just 2 forward slashes and then the $sign in quotes. Regular expressions are ways to deal with different character types and ways to escape different characters and combine characters together. You can do things like address uppercase and lowercase all at the same time. It is far beyond the scope of today's tutorial. So we are just going to sub the 2 forward slashes $sign with nothing. We don't want to put anything there. And we're going to tell it to do that for the meals one price column. Okay. Run that piece of code, and then let's go check it out now. So we'll check out the head of meals one and run that. And excellent, look, we have a column here with no $signs. Now, that doesn't mean that it's numeric yet. You see, it's still going to be in this character format because we haven't done anything to address that character format. So let's now force our prices to be numeric. So we're going to set the meals one price column, and we are going to say we're going to assign it to the as.numeric and then meals one price. So what we've said here is as.numeric for all of the values in the meals one price column. We're just assigning it to the same column name here. So you get this warning sign down here that says, hey, there were NAs in your data set, you just want to be aware of that. That's really fine. It doesn't do anything other than just say those places where there's no price, it becomes an NA. Now let's go ahead and glimpse our meals one again and see what we get. And here our price is DBL, and that just means that it's a number. It's analogous to integer in the summary format. So if we go summary, meals one, run that, it tells us that our price is numbers, and we can actually get a breakdown with the minimum and the maximum. Now, we can already see it here that our maximum price is probably way more than what we ever wanted it to be. But if you're looking at a bigger data set, you're probably going to want to either make a histogram of your numeric columns. So for us, that's meals one price. We go ahead and run that. And we can see that there's probably a problem because price should never be between $300 and $400. If we go back up and look at our data set, we see that there's a $400 value here, which was somewhere back up, but anyhow, we see that there's a $400 value. Since all of our values are somewhere between $250 and $10, we can safely assume in this case that there was simply a typo, and that's probably meant to be 4.00 as opposed to 400. So we want to make sure that that's the only issue, so we're going to type unique and then meals one price, and this will tell us all of the unique variables in that column. And it looks like we have an NA, 5, 10, 2.5, 6, 12, 5.5. So we can very safely assume that this 400 actually means 4. So we are going to go ahead and replace just that value. And the way that you do that is you call the meals one price column, and then you say find where the meals one price is equal to 400. Okay. And then we're going to set that equal to 4.00. So let's break that down. So we have our meals one $sign price, that's called our column, and then we've said where meals one $sign price is equal to 400. So it's found the location within this data set of everywhere that we have a 400 in this variable. And we've set these 400s equal to 4. And that will go ahead and fix that typo. And we can look again at glimpse and then meals one. And it looks like our 4 appears now here. We could also do another histogram of meals 1 just to make sure that it looks how we expect it to look. So we'll do histogram or hist meals 1 $price. I'm calling my price variable here. Run that, and that looks much more like we would have expected. We have some really cheap meals, some mid-priced meals, and some more expensive meals in a range from $2 to $12. And it seems like there's no obvious outliers here. Okay, so now that we've cleaned that up, we want to look again at a summary of our meals 1 table. Go ahead and run that. And it looks like we have 2 NAs here in our price column. So our minimum is $2.50, our median is $5.50, our maximum is $12. But we have the 2 NAs now. Those 2 NAs appeared for different reasons. And we know that because we know this data set. One NA appeared because breakfast is not offered on Mondays, assuming that maybe people will eat breakfast at home, right? And we know this from looking at the head of our data set and from, if this were a data set we got from the internet, that information should be in the docs. It may not be. You may need to figure that out on your own, noting that, digging a little deeper and noting that the NAs appear where there's also no meal. The other reason we have an NA is that we had a to be determined, or a TBD, value in our price column, and that was in relationship to fish. So the price of fish was going to be determined. Now, we will have to reconcile those 2 different reasons later on, and this gets at why we can't always just drop or impute our missing values. But that's a problem for when we're getting ready to analyze our data, not a problem for when we're still in the midst of cleaning our data. Okay, so we also remember that our character columns had some extra white space on them. So we're going to go ahead and remove all of that white space. So the first column that had that was my meal column. So I'm going to call meals 1 meal, and I'm going to assign it to str_trim. And the trim function removes any white space. There's also a pad function that will add either white space or zeros, depending on what you need. But for our purposes, we just need to trim the white space off of our data set. We also had white space on our entrees, which was also a character column. And we'll go str_trim meals 1 entree. And finally, we have the potential of having white space, and we do have white space on our location column. And generally, it's just best practice that anything that's going to be a character column, you want to trim the white space on, unless you want it to be of a certain width and you need to add white space. But more often than not, I find myself trimming white space. Okay, so we've now set str_trim to our meal column, our entree column, and our location column, using the meals 1 $ variable name syntax. We'll go ahead and run all 3 of those. That should go really quick because it's really small. And now let's go ahead and do a summary of the data. Run another summary, and if we go up here, we can see that we have our meal, our location, and our entree are all the character class. We want to see if our stripping worked, so we'll pass head to meals 1, and that'll give us the first 6 rows, and it looks like it did. When we were looking at this before, breakfast was kind of moved over, and now it looks perfectly justified to the right. Excellent. So we see here that we have one more string-based problem that we need to reconcile, and it's in the entree column. Okay, so first thing I want to do is see what entrees I have. So I'm going to type unique, and then I'm going to say meals1 $entree to call the entree column, and run that. And it looks like I have salad, chicken, oatmeal soup, beef, omelet, chef's choice, pilaf, and fish, right? But I also have this empty character here. For all kinds of technical reasons that don't matter, R has not replaced this with an NA. So whenever you get a value that's just blank like this, you'll have to manually replace it with an NA. That's actually really simple. The same way that we replaced the 400 with the 4, we'll replace our empty space with the NA. So we will call the meals1 entree column, and then we will call the location where meals1, spelled entree, then we'll call the location where meals1 entree is equal to nothing, and we will assign NA to those locations. So go ahead and run that, and then if we type unique meals1 entree again, we should get NA. And that's what we want, because missing values in R are always replaced with NA. Okay, we're getting somewhere. We're looking really good. But we need to make sure that our character columns are actually character columns. So I'm going to go ahead and run glimpse. Again, run it up here. Glimpse, and I want to glimpse my meals1. Go ahead and run that. And it looks like they are character columns. If yours are still factors, then you can do as character. So meals1 meal, and assign it to as.character, meals1 meal, in the exact same way that we did with numeric earlier. Okay. Now, we still need to do a little bit more standardization, a little bit more cleaning up. We're in a place now where our data set is technically correct, but it still would be really annoying to use because we have uppercase column names, which I personally hate trying to remember when something is uppercase or lowercase. So I'm going to make a new meals data set, and this is where I'm going to do my very last few things. And I'm going to call that meals2, and I'm going to assign it to meals1. And we're going to use this bracket notation that you haven't used before. So I'm going to open a square bracket, put a comma, and then close the square bracket. And what this says is give me all of the rows and all of the columns from meals1, and make that meals2. Go ahead and run that. And you see up here, you might have your global environment listed, and you'll have a meals2 data frame that has is exactly the same as meals1. Okay, but we are going to make a few small changes to meals2. First, I want to make sure that meals2 is exactly what I wanted it to be, so I'm going to check out head of meals2. Great, that looks about right. I would run summary and glimpse, but in the interest of time. Now, I want to make all of my column names lowercase. And the way that I'm going to do that is I'm going to say names, and then I'm going to pass it names meals2, and the names refers to the header. And I'm going to assign the names for meals2, and I'm going to say two lower meals, or two lower names of meals2. And what's going on here is that I've said, okay, give me all the names of meals2, make them all lowercase. now set this list or vector of names equal to the names of meals 2. So replace the names of meals 2 with the lowercase version of meals 2. I'll go ahead and run that. And if we do summary of meals 2, you will see that we now have all lowercase column names, all lowercase variable names. This is useful just to make sure that your data set is formalized and standardized and things like that. Now I'm going to do one more thing just for illustration, and I'm going to lower the column. I'm going to lower the values in the entrees column. A lot of times you do this when you are doing text pre-processing. That you don't want Bowie with a lowercase b and Bowie with a capital B to be different words. But in our case, it's just a good standardization practice. So we'll have meals 2 entree, we'll call that column, and we will assign that to lower meals 2 $entree. In this case, we are going to replace all of the entree names with their lowercase versions. So we'll go ahead and run that. And then if we ask for a unique of meals 2 entree, you'll see that everything is lowercase, including these internal words. So it's not just that it'll lowercase the first, but it'll lowercase everything in the word. Like I said, this is really common practice when you're doing text pre-processing. Okay, now we have finally gotten to a data set where we can say, okay, this looks pretty good, this looks nice and clean, we can go ahead and use this. So let's ask 2 questions. The first question is, if you wanted to know the mean and median prices of a meal in the cafeteria, what would you do? So let's say I just want to know the mean, and you can follow the same steps to get the median. All right, so I'm going to type mean, and then I'm going to pass it the meals 2 price column, and I'm going to say na.rm equals true, meaning I want to remove all of the NAs. Because what I'm getting is the mean, that's probably completely fine, because we would assume that the price of those 2 meals would be on par with the other prices, right? So I'm going to go ahead and run that, and I come out with 6.23, so about $6.23 per meal per day, right? Now, what if your question was actually, how much money do I need in order to be able to buy lunch every day, or to buy all of my meals in the cafeteria, right? This is a little bit more complicated, because what you're trying to estimate now is how much is the most amount of money that you should budget. And you would like to set your budget so you have a little money left over, as opposed to being a little short on Friday and not being able to have dinner, right? So we need to figure out what the maximum price was. So I'm going to set a variable, max price, and I'm going to assign it to the max of the meals 2 $price column, and I'm going to remove the NA values because they'll actually throw off our ability to calculate this. So what I'm saying here is give me the maximum price excluding the NAs. Go ahead and run that, and then ask it to print max price so I can find out what is the most expensive meal. It looks like it's $12. Now, even though in our data set there's only one $12 value, it's still going to be better for us to fill in our NAs with $12 rather than $6.23, because what we're trying to figure out is how much we need to budget in order to be sure that we have enough money to pay for all of our meals. Okay? So we're going to make a new column because we're going to be replacing values from our original data set. I'm going to call this meals 2, and I'm going to call it price underscore imputed. So I have calculated a price. And I'm going to set it equal to meals2 price. And that means that I just have two columns that are exactly the same. And now in my meals2 $price imputed column, I'm going to say anywhere that it is .na meals2 $price imputed. So anywhere that meals2 price imputed is NA, so the value is empty, any location of that in this column is going to be assigned to the max price. So we will go ahead and run both of these rows, and then let's find out what our cost is for the entire week. So we'll type sum meals2 $price imputed to tally up all of the values in this price imputed column. We run that and we get 105. So we would need to budget $105 in order to have enough money to eat in the cafeteria all meals for the entire week. All right, so this is just scratching the surface of what you may confront when you're dealing with a data set that you get from an unknown source, or even from quite a reputable source. If you feel comfortable with this, go ahead and walk through the cleaning the H-1B visa dataset. I've written out the code in R. I've not made a tutorial for it, but you can go ahead and walk through it and try to understand why we're doing each step for each column. And that's it for this tutorial. You can go ahead and save it up here by clicking on the little floppy disk and save it somewhere on your computer so that you have a reference of how to do all of these steps. Go ahead and download your histogram and send this to me as your tutorial output. All right, thank you so much and have fun with the H-1B dataset. Till next week.